Okay, well, welcome back, everybody. Now we're going to get to the section where we're going to talk specifically about the mapping aspect. I know we had some hard copies printed out there. Feel free to look on them as we go. If not, I've highlighted some of these. The idea is to familiarize yourself with what the maps look like, what kind of information we're talking about that are on them, and potentially what you need to know about. So, following up, we had talked right before the break, talked about cross-section and transects. Transect is just our coastal application. So our transect basically shows the profile going up the beachhead, if you will. It's all the way from out here past the shoreline up to what our limit of wave action is. And once again, you see in here we delineate velocity zone, which is what? Wave height greater than 3 feet. Coastal A, wave height less than 3 feet. And then our X zone, supposedly where we're not going to have any flooding. Here's our cross-section topography. Remember we talked about the Manning's N for roughness scale? Yeah. This is where this basically falls in. And you'll see it'll populate the picture in a minute. This is our floodway that we talked about. Once again, a different profile, unique to what you won't see on the firm. Obviously, we don't have this information on the floodway insurance rate map. But here's where we're talking about that roughness. Tall grass, concrete, regular grass. So here's our stream channel. Anybody remember what the bottom of the stream channel called? Dalweg, yeah. And once again, the idea is we don't need to memorize what the roughness scale is for tall grass or concrete. Just knowing that this information is important because this is how we determine the velocity of the water movement in the channel. So here's where we're tying some of these in when we talk about profiles, how we tie this in with what we're seeing on the flood insurance rate maps. Because once again, remember what I said, they're not standalone items. You're not just going to get all your information from the profile or all your information from the rate map. You use them in conjunction. That's why I said a good idea is once you sit down, get everything out so you start familiarizing yourself with what it looks like.
Hey, Mike, can I ask you a quick question?
Sure.
On one of the earlier slides, you had greater than 3 feet as far as the
Velocity zone?
velocity zone.
Yeah, the velocity zone, our wave height greater than 3 feet
Yeah,
is the V zone.
right.
In coastal, if it's less than 3 feet, it's typically the A zone.
Okay.
Yeah.
Right.
Don't get confused on the wave height though, because obviously if it's an AE zone in riverine, there are no waves.
Okay.
The big thing is to know though, with your wave height greater than 3 feet, it's the velocity zone.
Right. Thank you.
Yeah.
Do they mark something different for coastal A zones as opposed to just regular A zones?
Yeah. Let's go back to that. They'll call it coastal A. There's a little bit more depth to this than probably what we need to know as general information, but a lot of that coastal A is what's now being developed as part of the LMWA, the limit of moderate wave action. And that's that area that's delineated when we say, hey, we know that wave action is going to be to its extent right up here, and this delineates where our coastal A is. It may not be high enough wave action to be the velocity zone, but we're still in an area where we know there's some wave action that creates our coastal A.
Does the wave run up go to the X?
Yes, it could, yes. It doesn't have to.
Doesn't have to.
But wave run up, and if you're unfamiliar with that term, wave run up is just the amount of activity and force. Because think about it, when I got waves coming up here, as the coastline tapers up to nothingness where we're on shoreline, that energy from that wave force has to go somewhere. So his question was, does it go up to X? It can. It doesn't always have to. That's not a hard and fast rule. That's why when we do coastal construction, our studies require wave run-up analysis as well.
That would depend on the storm surge and the height of the storm.
It would depend on, it depends on what you're projecting for the storm. It depends on the bathymetry out here, the depth of the shore. Does it drop down to here, or is it a long, shallow shoreline?
It also depends on the on lower high tide.
Lower tide, yeah. It's all those combinations. What's the astronomical tide? What's the shoreline look like? The direction of the storm? So let me get you back. So on flood profiles, as we talked about before, These are used to determine the BFE for an area in the floodplain rather than the firm. Why? Because the firm rounds them up. The firm rounds that number and the profiles don't. So let's look, and if you have, this is the Rocky River profile, so if you happen to have one of those, if not, we'll work through this here. Showing you how all this works, down at the bottom is the legend, and we have the 500, the 100, the 50, and the 10. And that's what these lines are here. And we're going to look at a couple of these, so we have one or two that are better resolution as well. The general idea is I can tell you what the height is in elevation based on these profile lines. Because you notice these lines aren't straight across the table. And as we go, and some of the other things to note are where roads cross the riverbank, delineated by these eye shapes or the bridges. And believe it or not, these eye shapes are shown at the exact elevation. So that eye, if you visualize it's an I-beam on a bridge, that eye right here and right here are the crossings, that's the actual bottom of the bridge and that's the actual top of the bridge. So somebody could show you a flood insurance rate map and say, what's the elevation of the bridge at Oaks Drive? That's the bottom of the elevation, that's the roadbed elevation. Those are drawn to scale, to height elevation. So the ability to come over here and count and say, okay, that's 5 feet, and interpolate that's 10, so you count up, it'd be like 7.2 feet when you count those little boxes. And I'm not counting on this one because I'll show you I got a better slide with better resolution. But just giving you the idea that these are drawn to that kind of scale.
Are they looking for elevation of the base or the elevation of the road?
Well, they'll ask you.
They'll just say,
Yeah, they'll say, yeah. And think about it, if you had a client that was asking you that, they're talking about, hey, I want to rebuild the bridge. What's the current base elevation now that I need to make sure I adhere to if I reconstruct it? Think about, when you do a lot of this, think about putting this in a real world perspective. Because I mean, those are the kind of things that you look at, much like those are the kind of questions people want to ask, much like those are the kind of questions that somebody could ask you on an exam. They're all real world questions. We get that from the building department. Most of the time when you take code-related tests, has anybody taken any ICC tests in here? ICC tests are kind of the same way. They'll ask you some specifics of the code, but then they also kind of put it in perspective, like a contractor wants to do this, or a homeowner wants to do this. That'd be like the example here. A bridge engineer says, I want to reconstruct the bridge on Oaks Drive. What's the base elevation that I have to have the bottom of the bridge be at? Could I get that information from just the firm? No. The firm shows me where it crosses Oaks Drive, but it doesn't show me the height. So when we talk about maps, let's talk about some of the fundamentals, and then we'll work into the specific details. First off, I have my community name. Here we have good old Flood County, USA. And then down here you notice that I have more than one. Here I have Flood County, then they have the town of Floodville. I could have numerous specific communities in there. Just because it's Flood County doesn't mean the whole place is Flood County. There need to be some specifics. The reason that's important is these have different NFIP identification numbers. If you have one of these maps in front of you, you can see what I'm talking about. While it's all Flood County, USA, I can have different communities on the same map that have different numbers. Seems like an insignificant detail, but it's really important because if I'm looking and if I'm identifying these community numbers, which in turn relate to how I'm going to show them on the elevation certificate, I need to make sure that community number is correct. Following that, I have a letter. The letter corresponds to the number of revisions of that specific community, not the whole map of that specific community. Most of the time they're the same, but they don't always have to be, so be clear on that. By letter, I mean A, B, C, D, accordingly to revision. So here they're a D, that's what? Fourth revision. So that's the only way you can tell what revision you're on. So if you're looking for the map, don't look for the word revision anywhere, because guess what? It's not there. You have to know that's what that suffix letter stands for. And then if somebody said, what's the effective date? It's pretty straightforward, but that's on the front page of the map. Hopefully when a community is using this, they're using the most recent effective date. If they're not, they could be in violation of the NFIP standard. That's one of that regulatory things that says, hey, the federal government made the rules. Remember when we talked about that mutual agreement earlier? The federal government made the rules. You as the community are going to enforce them, and we would hope that you're using the most effective, the most recent date as the effective map date. That's why we spend all the trouble going out there and remapping everything, hoping that you would use the most recent. So here's our legend. You have to memorize all this, correct?
Yeah, exactly.
Yeah, exactly. You do not have to memorize it. If you have the legend in front of you, take a look at it now. If not, we can go through this one. It's just if you have trouble seeing that print. The legend defines all that you're going to see on those maps. You don't need to memorize it. It's right there. And lo and behold, look what we see. We see all those same zone information. We see the area delineated as the floodway. The gray box with the diagonal line. So if there's any question when you're looking on the map what the floodway is, if you see that diagonal lined area, go back to your legend and say, yeah, that is the floodway. And then here's Kirk's favorite area, flood X, with that whole shaded, unshaded thing there. And then our other areas, X and D. What do we say? D is doesn't flood, right?
No.
No,
It has
D
to
does
be
not mean doesn't
determined.
flood. Areas where flood hazards are undetermined but still possible. It doesn't mean doesn't flood, so don't get that confused. And then over here we see our floodway boundary, we see our zone D boundary, base flood elevation line, elevation in feet. So when we look at the graphic part, we'll see where that number is. Is that my regulatory number? Everybody should shake their head no. Please say no. Even if you don't understand, just say no and I'll tell you why.
That's
Because-
roughly, right?
Because remember what we said, they're what?
Rounded.
They're rounded, exactly. So while that, in this instance, 513 is the elevation on my firm, the regulatory number may be 512.9 or 513.1. So if somebody asks me, hey, just tell me what it is off my firm, the general number, I'm going to tell them 513. If somebody's talking about building a house in this area, or if I'm trying to fill out an elevation certificate or give them a quote for an insurance policy, I want the regulatory number out of the flood insurance study. Here's our cross-section. Remember, what do we say about cross-section? They are always in hexagons.
Stop sign.
Yeah, they're always in stop. Well, no, stop signs are octagonal, aren't they?
Yeah.
Well, you don't stop for those signs, do you? That's I'm always slightly scared now. Hexagonal, and they're always what? Letters. And we're going to see something really important when we look at the map picture in a second that you need to remember about cross-section.
One other thing, when the letters go up, what direction in the river are you going in?
Usually it's moving downstream, but not always. And I say that because that's the caveat that you have to look where they're either denote on the stationing distance that it may say on the map, or in that measurement that we talked about before on the data profile, where it talked about distance away from a given point.
You have zero stationing at the mouth of the end of the river.
It'll tell you that. That's why you just can't always assume, because if you have one, in our example, we'll see where it'll say where the beginning of the floodway is, and then you know where they're coming
A
from.
while ago on that diagram, all the feet in the letters as they went down went higher.
Correct. So you would assume that from wherever that point is, as it goes away A, B, C, it's moving farther. What you have to be careful of, Bruce, is
It's
that.
running deeper is what I meant. It's not farther, it's deeper. And feet.
Well, no, that depends in depth. What they were delineating is how far it was from the point. And the point you have to be careful was is it may either be the county line, it may either be the point of origin, it may be a reference benchmark. They'll tell you where that is,
Where?
but you're going to have to look on the map.
On the map.
Yeah, and I'll show you an example of that in a second. And there's our elevation benchmark, there's our river mile, there's our effective date of revisions, And something very important, the scale. So when we talked about measurements and distance, like of a cross section, we're not going to scale it off the map. But if somebody asks me to scale something off the map, I can use that scale. It may be as simple as me taking a piece of paper and making 2 tick marks on it and say this is 500 feet. What you have to be careful of is not every map is scaled to 500 feet. Don't assume that every flood insurance rate map is always 500 feet. It could be 1,000 feet.
And we gotta do this manually.
Correct. Yeah,
Make
so,
your own scale.
yeah, and that's as simple as taking a piece of scratch paper and holding it up there and saying, okay, here's 500 feet mark.
But you can also use an engineering scale.
No, because you can't use those.
You don't have one.
Yeah. They don't give you one. It's just,
I brought one.
well, they don't let you use it. I'm supposed to snap it in half. No. I take it, I grab it, I snap it in half, and I give you the piece. So don't let the scaling or the measuring worry you, because we're not even using tools to do it. We're just going to use your piece of scratch paper to make the tick marks. So you figure by doing that, the detail is not that great. The thing you have to remember, though, is make sure you look at the scale of the map. And you don't always assume that it's always 500 feet. So one of the important things on this, and I intentionally skipped over because we're talking about it right now, undeveloped coastal barriers. These fall within the bottom. It says coastal barriers are normally located within or adjacent to special flood hazard areas. So I'm going to go to the next slide so you see what we're talking about. Coastal barrier resource areas, COBRA zones. That doesn't mean there's a lot of snakes there. COBRA zones and OPAs. OPA. Everybody know what that is?
Other protected areas.
Otherwise, other protected areas. Yeah. We're not Greek and celebrating OPA. You know. They are not eligible for flood insurance if built or substantially improved after specified dates. Do we have the specified dates committed to memory?
No.
Do we need to? No, because guess what? They're right there on the map. Based on the cross-hatching of that area, and I say cross-hatching, diagonal lines, solid diagonal lines on this map are identified in 1983. Dashed ones are identified 1990 or later, and this otherwise protected area is identified 1991 or later. So now here's where we turn the regulatory into what we can read on the map. So let's see what this says again. Buildings in coastal barrier resource areas or otherwise protected areas are not eligible for flood insurance if built or substantially improved after specified dates. So if I go back to my map and somebody has a house that they have and they live in this area, and on my map right on the coast I see these diagonal lines. And they might have flood insurance now, but they have a fire and they have to rebuild it and it's substantially damaged, which leads to a substantial improvement. Can they buy flood insurance now? No. This surprises a lot of people. People have really nice homes on the beach. They have homes on really nice islands. Something happens to them, storm, fire, what have you. Then while the community may allow them to rebuild it, they don't have the option for flood insurance. How this ties back to the map is depending on when that day is. If it's damaged, they still, whatever the day is, they still can't carry flood insurance. But that was the original date of when that area stopped being able to offer flood insurance for newly constructed area, newly constructed buildings.
I'm sorry, Mike, I don't see the dates on the one that I have. What are those dates again for the
Uh, In the legend, you don't have dates on yours?
Yeah, they're in there.
They're where? Am I looking?
Should be on the legend.
It's on panel 40, it's not on panel 38.
Oh, I'm looking at the wrong one.
Which
I'm
one?
looking at the wrong one.
And
Which one? 38?
Yeah, it's only on panel 40.
correct. And why do you think it's only on panel 40 and not on 38?
Because that's
Because on panel 38, there might not be any of these on that map. Another little hint is sometimes if there's just one of these areas on the map, they may actually show it on the map, write it in that area, but they don't show it on the legend. But basically what this is telling you is areas built, following this slide again, areas built within that zone, and that zone is delineated by the lines on the map, typically near the coast, after those specified dates are not eligible for flood insurance.
All three of those.
Correct. Then the three are differing by dates of when that Coastal Barrier Resource Act went into effect there. And the reason there's three different ones, in 1983 we said, hey, this area should be protected. And then following in 1990, we're like, whoa, we should protect this area too, because it's important. And then subsequently in 1991, we're like, yeah, this area needs to be protected too. So they just didn't keep making the original area bigger, they started adding to it. So you could have a map that shows these in three layers on the same area, where it looks like little slices of pie, if you will, or different layers from here heading out to the coast. Where they said, hey, originally we thought, protecting within a mile of the coast was important, then we made it 2 miles, then we made it 3 miles, but each one of those has a different pattern based on the date. The importance for you being able to read that off the map is if somebody told me at what date would a house be able to be built there originally and still carry flood insurance. And it's just a matter of saying what would have been the date that I could have still built a house here and carried flood insurance, been able to buy flood insurance, as opposed to not being able to buy it. So do you think any one of these coastal barrier areas right now, if I buy a piece of property there and build on it, can I buy flood insurance?
No.
No, because we're way past that. The community still may let me build there. They still may sell me a building permit. They still may say, have at it, but I'm not going to be able to buy flood insurance. Which in turn probably means that if I'm seeking a loan or some kind of funding, it's not going to be federally backed because they're not going to cover that. So I may be self-insured, I may be borrowing money from the private sector, I just may be rich enough that says, hey, I don't need to have flood insurance. Yeah, pretty much.
You may not be, you probably wouldn't be able to get a loan to do it either.
Probably not unless you're borrowing it from some guy on the street at like 23% interest.
More likely,
And he's like me, his last name ends in a vowel, and he shows up and breaks your legs if you don't make a payment. But
more likely it's a cash bill.
yeah, and his name's Guido. Yeah, I think that's some of my relatives actually. So the idea is that we're talking about areas that are on the coast. So think about it. I don't think it was made to work this way, but typically the people that can afford those high-end beach areas, they're probably going to self-fund it anyway.
Yeah.
You don't have people like me, the middle class, living on property that's going for $1 million an acre on the beach. Or if I did afford to buy the property, I can never afford to build anything there because I can't afford the construction.
You're getting money into the table somewhere.
Exactly. Yeah. Not necessarily, but somebody is. So that's the important aspect of that. I mentioned that because a lot of people get confused on this whole concept, coastal barrier resource areas. How do I know where those are at? How do I know the dates? You don't have to know any more than what the hatching pattern is and what the date is by the legend. As she found out, if they're not always on the legend, you may not have one on your map. Or if you do have one on the map, it may say specifically, this is a coastal barrier resource area from 1983. It's straightforward, just don't get caught up in the numbers, because once again, this isn't something we have to worry about memorizing. You just have to be able to read that scenario that says, hey, since when can I build a house here, or since when haven't I been able to build a house and carry flood insurance based on those dates? An additional map feature, you don't see this a lot, but it can occur. The curvilinear line for erosion is the border on either a flood hazard boundary map, and we'll talk about those, or flood insurance rate map that delineates the special flood, mudslide, mudflow, and or flood-related erosion hazard areas, and consists of a curve or contour line that follows the topography. So in areas where you have the potential for mudslides, mudflows, erosion, any kind of geographical feature that may be related to flooding, they may show you a special delineated line. The important thing here to know is what the term is. So if somebody would ask you, hey, what's the curvilinear line designate on the maps? It's essentially related to erosion. Whether that erosion is in a mudflow, a mudslide, slip-off slope, the general idea is that it can delineate erosion.